Welcome back to another Explainer. Today, we're embarking on a real cosmic detective story. We're pointing our instruments toward a galaxy that, frankly, breaks all the visual rules of what we expect to see up there in the night sky. We're investigating the bizarre geometric anomalies of ARP 153, though you probably know it better as Centaurus A.
Okay, let's dive right into this. 11 million light years away. That is the staggering distance we're traveling today, straight into the heart of the Centaurus constellation. Now, sure, 11 million light years sounds impossibly far, right? But cosmically speaking, that's practically our own backyard. And because it's so incredibly close to us, Centaurus A gives us this totally unique opportunity to study the inner workings of a highly active galaxy in just mind-blowing detail.
So here's our mission brief for today's investigation. First, we'll meet the cosmic giant itself. Then we'll tackle the infrared parallelogram mystery, followed by those weird S-shaped filaments and shocks. After that, we'll break down the anatomy of a merger, and finally, feeding the monster.
All right, part 1. Meet the cosmic giant.
Now, what's really interesting here is the sheer, stark visual contrast. I mean, just think about it. When you observe Centaurus A, you immediately notice this massive, glowing, elliptical body beautifully surrounded by these delicate stellar shells. But then, slicing right across its equator is this dark, chaotic dust lane. It completely hides the active galactic nucleus from our direct view when we look in visible light. It's like it's deliberately keeping secrets. To truly appreciate this thing, we need to understand its absolute heavyweight status. It's a dominant member of what astronomers actually call the Council of Giants. Sounds epic, right? It's basically this exclusive club of large, heavy-hitting galaxies in our local universe. Centaurus A is also classified as a lenticular dragon. Now, I know that sounds like pure science fiction, but it really just means it's a massive disk-like galaxy that acts as a double radio source. It's blasting these incredibly powerful jets right out of its active nucleus. Like I said, a true galactic heavyweight.
Moving on to part 2, the infrared parallelogram mystery.
I want you to really think about this for a second. What causes a giant geometric square shape in space? When the Spitzer Space Telescope peered into the core of Centaurus A, it didn't find a smooth sphere. It didn't find a perfect, elegant spiral. Nope, it found a massive 3 arc-minute-long parallelogram. And let's be real, in nature, especially in the absolute chaos of space, sharp right angles and straight lines are practically impossible. So what on Earth, or rather, what in space, is going on here?
Well, thanks to mid-infrared imaging, we know this isn't a solid square bar at all. It's actually a giant cosmic optical illusion. It's caused by folds in a thin, dusty, highly warped disk that we just happen to be viewing almost perfectly edge-on. These overlapping folds completely trick our eyes into seeing a geometric parallelogram. And what's wild is that this illusion is actually a major, thriving site of active star formation. And this brilliantly illustrates how we figure this stuff out. By mathematically mapping the inclination and the overlapping orbits of all that gas and dust, astronomers can literally recreate that exact parallelogram shape in their models. It is such a beautiful, elegant translation of raw physics into a solved geometric puzzle piece. Which brings us to part 3, S-shaped filaments and shocks. When you compare the raw, chaotic data of molecular gas swirling around the center to the clean schematic diagrams that astronomers extract from it, it's just mind-blowing. This is exactly how scientists decode that absolute massive data to discover highly distinct, beautifully symmetrical S-shaped filaments hiding right there in the inner regions. Now, these twists, they aren't just gentle little streams of gas. No way. These S-shaped filaments are actually intense nuclear shocks. Deep inside this central ring, the gas is definitely not moving in a nice, smooth, polite circle. It's experiencing extreme non-circular motions. Because of this, the gas is violently colliding with itself, creating these massive shock fronts all along that S-curve, where it rapidly bleeds off its rotational energy. If you want proof of just how violent this environment is, check out the velocity data from the submillimeter array. Right along those very shock fronts, astronomers measured a steep, incredibly sudden velocity drop of about 100 kilometers per second. Let that sink in. That is a massive cosmic braking mechanism happening in real time. It proves beyond a shadow of a doubt that these non-circular shocking motions are absolutely real and undeniably powerful. All right, part 4, anatomy of a merger. Let's look at the history.
You see, galaxies are not static, peaceful objects. They are dynamic, colliding beasts. And Centaurus A, it has a seriously violent past. Picture this. About 700 million years ago, this massive elliptical galaxy approaches a smaller but incredibly gas-rich spiral galaxy. Then, around 500 million years ago, boom, a violently chaotic collision occurs. The giant elliptical essentially rips the gas right out of the smaller galaxy, throwing it into these wild, chaotic Keplerian orbits. Fast forward to today, and that exact resulting debris is what forms those massive stellar shells, the warped disk, and, yep, our mysterious parallelogram.
So the absolute crucial point is this. Elliptical galaxies usually do not have all this cold, star-forming molecular gas. They just don't. This ancient merger literally injected foreign, non-rotating gas directly into the heart of the giant elliptical. And because this material was basically an invader, it wasn't supported by the galaxy's natural rotation at all. This created a highly unstable, totally warped, and completely chaotic environment. This ancient merger is the smoking gun. It's the direct cause of every single geometric anomaly we've investigated today. And that leads us to our final section, Part 5, Feeding the Monster. Let's see how this all builds into the ultimate cosmic feeding mechanism. It happens in steps. First, that foreign gas hits those S-shaped shock fronts we talked about, slamming on the brakes and losing a ton of its angular momentum. Second, all that slowed down material funnels inward through a massive 400 parsec circumnuclear disk. Third, it travels even further down along these super hot, incredibly tight nuclear spirals. And finally, all of this perfectly funneled gas is delivered right to the doorstep of the supermassive black hole. That is exactly how the monster gets fed. The researchers investigating this actually put it perfectly in their paper. They called it a mechanism which may feed efficiently powerful radio galaxies down to parsec scales. By solving the geometric mysteries of Centaurus A, we aren't just staring at some weirdly shaped cloud of dust. We are literally witnessing the exact mechanical process of how the most powerful active galaxies in the universe sustain themselves and power those massive, mind-bending jets. It's incredible. Which brings us to one final, kinda chilling thought. Our very own Milky Way, it's currently on a collision course with the Andromeda Galaxy. So I leave you with this question. Hundreds of millions of years after our two galaxies finally merge, if a distant observer looks back at us from, say, 11 million light-years away, will they see our own chaotic parallelogram? Will they see it hiding a newly fed, highly active monster lurking in the dark? It completely changes how you look at the night sky, doesn't it? Thanks so much for joining us for this explainer today. Keep your eyes on the stars, and we'll see you in the next one.